Welcome to Advent of Code in Fstar. Let's see, what day is it today? It's day 9. So I'm going to get set up here. So I yesterday I did not manage to solve the second part. That what's going on in part 2 of the problem is there's a lot of logic that's going on that's hard for me to express. Things like, well, of course there's one of those because we guaranteed it. And so one of the things I was running to is having to assert a lot of things were true, and that's always a bad sign. We'd prefer to prove that they're true. So I think a better model is to define types that say, well, here's what we know to be true, and then one step in the inference later, we know what else is true. And I think these aren't quite the right things, but this structure would satisfy a lot of things like, well, how long is the list, and what's the cardinality of the number of segments, and then we can write our inference functions, uh, and they look sort of like if then. If we use to formal logic, it says, well, if we've got an initial state, then we've got a state after 3. So if x, then y. And that's sort of what dependent typing is like, is you can read this either as a function that computes after 3 or proof that there is a type of this form, which again, I don't think has everything we want in it, given the initial state. So I think this would be a very compelling way to solve the problem if I could get all the pieces to fit together. And so I had early this morning I explored a little bit with like, well, can we define sets of all the types? But then sets in Fstar don't have cardinality defined on them. So do we have to define that so we can do it? And there's just a lot of pieces that need to come together. The puzzle is, it's sort of a simple uh, it's a simple logical puzzle, but expressing all that logic uh, was hard for me. So let's get started on day 9. Okay. These caves seem to be lava tubes. Okay, so we've got a height map. And we need to find local minimums. So points that are lower than any of its adjacent, and diagonal don't count as adjacent. So there are 4 low points. Okay. How big is our puzzle? Kind of big. Okay. So get started on day 9. Create our new file. So if you're new to the stream, Fstar is a dependently typed programming language, which means we can create very expressive types to say things about what we're operating on and what our functions are really doing. And the downside is if we do that, then it's very fussy about, you said this was length X, can you prove it's length X? And that's caused me a lot of grief over the past couple days. So what I'm going to do is I actually built a lot of code for dealing with a matrix and reading it in during my warm-ups. So not that I actually finished the puzzle, but last year's day 11 was a cellular automata. So I had built the code to look at the neighborhoods and reason about this, and it got it to a somewhat working state. So we're gonna copy that. Some of this vector and matrix code I used in a previous one. Okay, so a vector is just a list that's a fixed length. A matrix is a vector of vectors, and we've got a width and height specified. Non-zero, we've got a function to look up a particular value, and these are all parameterized by type. Okay. So our function to get neighbors. All right, so that's that was parameterized with the what was I doing here? Oh, I see. Okay. So this is the helper function, and what it does is it says if you're out of bounds, then we just return the old list. So we take a position, we take a delta, we take the existing list, and if the x plus dx and y plus dy are in bounds, then we add that value in to the list. So this needs to change. This neighborhood function. I'll make my screen share big, my screen larger. Maybe not that large. All right, and so for this year, this problem, the neighborhood is just the orthogonal. So we want +1 and -1. Right. So we just want 4 neighbors. So let's see if, oops, that's a list of natural numbers, since we're storing natural numbers this year instead of I should have just defined cell contents to be natural numbers. All right. So the transition function is different. Well, here's all this crud. So this is code to generate a range of natural numbers. So I wanted this so we can iterate over, the whole matrix, the whole zero to width and 0 to height, as a list. And so maybe that is too fancy. Maybe we should just do it as its own recursive function. But since I put all the effort in to make this work, Might as well reuse it. I've been thinking about putting this in a library, and maybe we should refactor to do that. But what it does is it proves that if we start at 0 and go to say the width, then the length of that range is actually the width. So we know that if we map over a matrix, we look at that many elements, which may not be necessary for this solution. But all right, let us copy and adapt the parsing code. Okay, because I don't think we were given how big. I don't think we were given how big it was, and the example's a different size. So we're just going to read the first row, and everything else has to be that wide from now on. And we're going to read however many. Read the first row, and that's how wide it is, and read every row, and that is how many rows we've got, the height. So what was I doing here? Do I actually use parse char? I don't. Okay. All right, so parse row takes a string and expected length and returns a vector of that length, or none, the none constructor if it doesn't match. And it converts the string to a list, and this works over the list and creates vectors one row at one cell at a time. Okay, so if expected length is 0, then we better be at the end of the list. Otherwise, okay, so we recursively parse the rest of the lists, and we're not being nice and tail recursive here. But then here's where we got to turn numbers into characters into numbers, and I'm just gonna brute force it. You may have noticed if you've been watching around that Fstar's library is nowhere nearly as full featured as say Python, so we do have a character to Unicode. All right, but how would I? How would I tell it? All right, I'm gonna leave that be. We can come back and fix that later. We do have character to Unicode number, so we could do better there. All right, does that work? There's the auxiliary. So we have a little dependent type here that stores the width and the height. A little constructor. Okay. Hey, that was quite possibly the fastest Fstar parsing because I done all the hard work I've ever done because I did all the hard work in the warm up. All right. So let's copy and adapt that. So parse. I'm going to just do this as calc part 1. So we okay. So this is where we're going to do the work. So we're going to map over the entire all right, so the old function applied a transition rule to every cell because it was a cellular automata. We're doing something simple. We are just returning a list of all the low points, which we're just gonna sum anyway. Yeah, let's return the list. Except then we don't have an easy way to print it out anyway. Let's have a way to print it out. All right. So we're gonna give a list of. Let's do a list of coordinates. So a net that is x is less than the width and y is less than the height. Okay. All right. So we're given a y. We construct the list of the right type using our helper function. And we, instead of getting a new vector, we just want to filter the list. Okay. So we're going to do is minimum matrix. Which order am I doing things in? Y then X is what I've been doing. Y, X. All right, so that'll give us just the X coordinates. Be nice if there was a function that sort of simultaneously transformed and filtered. I guess we could do that with a fold. We do okay, we could do a collect. Applies F to each element of L and returns the concatenation of the results in the order of the original. So, yeah. So we return an empty list. All right. So we do that and we collect the map row. Sure. I think we don't actually need our fancy functions here, but they don't hurt. All right. All right. So is minimum given a matrix of natural numbers and the width and the height, and so what we want to do is return a list of inbound items. So we know it'll be either empty or not empty. Okay. So if our neighborhood of M, oops, we didn't do our Y has got to be height X. So this is like, like the static analysis tool that you might do to say, oops, you might go off the end of an array, except you have to prove it a lot more rigorously. So we can't just call a function and hope. I mean, we could. It has that facilities, but the reason we're doing this is to get assurance that we could never access past the end of an array or out of bounds of the matrix. So, all right. So if all right, so we want to say if everything in our neighborhood is greater or greater than or equal to lower than any of its adjacent. So all the neighbors are greater than value at. All right, so for each, okay, we're going to check that everything in the neighborhood is greater than the value in the center. And if it is, then we're gonna return the pair yx, and otherwise we're gonna return the empty list. All right, does that type check? No, it's unhappy. Okay, we messed up the bound. Let's try again. Oh, it expected type list int got type list now. If we don't specify a type. Okay. All right, let me switch these around so it's consistent. So I'm just using yx everywhere. Okay. I'm sure if I were a better Emacs user, there'd be something clever to swap these around. Expected type char. That's probably from the string library. So we want the list to collect. Wow. Everything type checked. That's amazing. All right. Okay, let's sum and print out. Print out and sum the values of that collection. All right. Sum. We want to take the whole thing. So oops. List, and we're going to return a natural number. Okay. Why is it complaining about a person? Oh, we didn't say give the argument a variable name. There we go. All right. So standard recursion. We could do a fold, but I don't think it would be any faster. empty list, then it's 0. Otherwise, it's yx. So it is value at plus get the syntax right. If it's recursive, we have to say it's recursive. We can define mutually recursive by putting an and in there, but haven't had to do that yet. All right, that type checks. And let's do a print. So same thing here, basically. Okay, y and then x. And then do the rest of the list. We didn't pull in. I'm confused. One of the things I'm still confused about is in the module system. Some modules you can just use fully qualified without opening, but Printf doesn't appear to be one of them. Fstar dot. Oh, it's the module's just called Printf. Okay, what am I doing wrong? Oh. There. The interactive mode gets fussy if you add new dependencies. Or you look at it funny. So congratulations to all my ex-coworkers at HashiCorp, whose IPO is tomorrow. Bet they're looking forward to that. All right, so we got our matrix. What are we going to do? We're going to solution is find local minima of the matrix, and width and height are implicit, so we should be good there. We need to give it the matrix as well. Yeah. All right, so let's do our usual thing and say, look at our example and look at our input. So, what does the example look like? What did I do with the input? Did I not copy it? I don't see it anywhere. All right. All right. What does this look like? Okay, so 0, 1 and 0, 9 and 2, 2 and 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6. And the sum of those values is the risk of a low point is 1 plus its height. Didn't read carefully enough. All right. So that is 1 plus that. All right. All right, let's try this 591. Ooh. All right. Now we need to find the largest basins. Basin is all locations that eventually flow downward to a single low point. For every low point has a basin, although some basins are very small. Locations of height 9 do not count. Okay. Find the 3 largest basins and multiply their size together. Okay. So I mean, it doesn't. The size is just the number of squares. So, I mean, to be honest, I'm tempted to just print it out with all the non-9 values replaced and see what it looks like. So we could count it by hand, maybe faster than I could compute this. Okay. All right. So one way to solve this would be with union find. Uh, that we just go along and we union find every cell with its neighbors. That doesn't really give us the sizes. We could calculate it from that though by taking another pass. Um, the other thing we could do is depth first search. Uh, in every point and mark the points that we've seen already. I kind of like union find. Wonder how hard it would be to implement in Fstar. I'm kind of the problem with depth first search is it's very imperative, and so that seems like it would be hard to do. But union find's kind of imperative too. You go in and switch the pointers around. Um, Yeah, I don't think I want to do that, but depth first search might actually be worse. Because the sets provided by Fstar are not constant time. Is that true? No, they're backed by bat sets. All right, let's do DFS. Is there an example of DFS? Doesn't look like it. DF. I don't know what DFST is. Oh, that's DFST is the first element in the dependent pair. All right. Okay, so no help there. All right. So what we're going to do is we need, so for DFS, we keep the matrix, our current position, and we keep a map from pairs of nets to pool. So have we visited, and we can do it recursively, so we don't need a queue. So we'll do, all right, that's okay. I'm a little worried. No, let's do a, set. All right. Can we reuse our neighborhood function? Not really. I'm a little worried. Do we have to carry over visited? Could two of the local minima be in the same basin, for example? It seems like they could. So we can't just go to each one of those. So let's take in the visited set. I'm going to get real tired of doing that. So pair set. All right. So I don't think we really need that. We're gonna return a list of sizes. All right. So all right, if we reach 9, then that is not part of it, and we don't want to go any further. That's not part of the basin. That's the border of the basin. We don't want to go any further. All right. The thing I'm having difficulty with here is how to pass this visited set around. because we need it back. If we, go right and visit that, then we need it set back before deciding if we should go on to the next one. Can we? Okay, the easiest thing to do is going to be remove the restrictions here and check them dynamically instead. So if y is greater than height, if x greater than width, then doesn't count. All right, we could do those all as an or, but all right. So now we can visit the neighborhood. And not, okay, we're going to pass in the each return value to the next. So visit each of the cardinal directions. Okay, it's going to give us a hard time because, okay, so if y is greater than h or y. I gotta relax it still further to integers. All right, and then we just return the sum. Okay, but we need to actually update visitor some. Okay. Okay, so we're visiting XY. So V0 equals update visited with, and we need to check it. Okay, look at this. All right. So this is not the most efficient version because it visits. It's going to visit everything 4 times and check that it's visited. But okay, so if member if yx is a member of visited, then we already counted it. Else update. No, it's a set. So it's set dot union visited and the singleton set singleton. Okay, and then with our updated set, we visit our neighbors, It does its thing. It does its thing, and then we have to count ourselves and the counts from all our neighbors. And I have to use Fstar syntax, not Python syntax. Oh, come on. Fstar is a research language from Microsoft Research. It's a dependently typed language that's a lot like OCaml. And I realize that probably doesn't help because OCaml is itself obscure. But it's dependently typed, which means you can augment your types with uh, parameters. So, for example, in this function here, we decorated the list and said, hey, it's not just a list of integers, it's a list of pairs of integers, and the y coordinates are less than the height, and the x coordinates are less than the width. So that's the sort of thing you can do in Fstar to give you additional type checking on the correctness of your program. You can even prove things about your program, which was a little hard to do for today's exercise, I think. It is complicated. uh, my programs are, oh, I forgot to change the module name. My programs are generally much longer than if I were solving advent to code in Python or Go or virtually anything else. Mad props to all the people solving it in R this year. I see a lot of those on Twitter. Right. Okay, I screwed up that. Replaced the wrong argument. All right, I screwed up a lot of things. I wish there was some way to say, hey, Fstar only use this parameter once. All right, so it's complaining that y isn't the right type. Because it needs to be a natural number in bounds, and it says, hey, this is just an int, which isn't, I think, true because I did check it up here. But maybe it didn't unwrap the Boolean, or maybe I'm off by one. Should both be true in that part of the code. Y, oh no, y is greater than or equal to. Okay. Y, okay. Yeah, it's giving me crap because I got the bounds check wrong, which is what it's supposed to be doing. But its error messages are not always clear. All right. Well, this is interesting. Okay, so we're making a recursive call, and it says uh, I can't prove that it terminates because the type of this function is implicitly which is total functions, which means they're defined for every value of the inputs and they always return. So um, so we could weaken the guarantee. We could say, well, maybe this function doesn't always return, or we could prove that it returns by giving an invariant. So the invariant would have to be that the size of this set increases and is bounded, but that's not enough. And sets don't have cardinality, which I ran into before. Thank you, Fern. So I'm just gonna make this just lower just move it to different effect and say, okay, well, it might run forever. I can't prove that it doesn't. All right, can I move this back? Okay, so all the bounds are correct now. I didn't prove that it terminates. It'd be kind of cool if we could do that, but I think we'd have to rewrite it, and it would still be complicated. We could maybe prove that the number of yeah, it seems very difficult. Which is union find would be a lot nicer. um, So yes, I am an Emacs user. There's a Fstar mode for Emacs that is doing all the syntax highlighting and translating things into funny variables that look more like math and funny characters that look more like math and sending things to the Fstar compiler in the backend to type check things a function at a time. And there's other things you can do. So, all right. So let's make this sizes of region. And what we're basically going to want to do is iterate over the whole matrix again. And whenever we find a cell that we haven't visited, and that's not 9, run our DFS and add that to the list. Why do I use Ubuntu? Because it's easy. Because I stopped I stopped caring about distributions a while ago, and I just run whatever the LTS version is. I think it's what we used at Tindry for No, it's not the case. I don't know how I got started on it. It was low effort. I got sick of fiddling with Linux. I kind of like the way we did things here. So I'm gonna try to adapt that. So is that gonna work? It's not because we can't pass the visited set around that way. So we're gonna have to do this in a recursive fashion rather than as a map. I have not given Mint a try. Maybe I will do that next time I spin up a VM. Um, all right, so I call this collect all region sizes. Going to iterate over y and x. We're going to take in our pairs that we visited so far, and we're going to take in our list of sizes. Mint, Pop, and Zorin. Wow, I've never even heard of Pop and Zorin. Obviously, I am hopelessly out of date. I'm swiftly becoming an old. um, all right, and at the end of it all, we want to get back a list. And since we're going to call this DFS, we have to have the same effect, even though we could more easily prove termination on this. So let's go. Shall we go from 0 up to? Sure. All right. All right. So if it'd be easier if we can go past the end. All right. So if x is at our width, then start over on the next row. So m y plus 1, 0, same pair set. Same basins. And similarly, if y equals is, if we're at the bottom, uh, then we're done. Otherwise, uh, so if value at myx equals 9, then just go on. Okay, so we handled the end of the row, we handled the end of the matrix. We handled the boundaries. We need to check, have we visited this before? So if member, no, set dot member yx of visited, then go on to the next x. Otherwise, otherwise we need to do our DFS. So let size, a new visit equals DFS of matrix y x, and we need to give it our visited Okay, so that computes the size of the basin, marks up the map, marks up, adds new things to the set. Okay. What I've actually been doing for several years now is I just run Windows as the outside and just run Linux, my development Linux as a VM. So that way I can play games. Can run Twitch Studio without worrying about will it work with my camera, things like that. So that's how I solved the hardware compatibility problem. Just everything's a VM, and that's got very standard, well-supported drivers in Linux. So. The downside is I can't do GPU programming, but I'm not sure I could on this laptop anyway. It doesn't have an NVIDIA chip. All right. All right. Otherwise, we're going to go on. We're going to do the new visit, and we're going to add this size onto our basins. Okay. Let's see how it feels about that. It got stuck. New visit. Okay. Let's swap these around. Okay, good. It was giving us a hard time because we said y could be as large as h, and then we added one, and it would be larger than h. So okay. So under the hood, Fstar is actually using a SMT solver. SMT stands for Satisfiability Modulo Theory. It's basically like a set solver, but it knows about arithmetic too. So it knows that if we originally said y is less than or equal to h, and we tested y equals h, then in the other clause, it must be that y is less than h. So it knows simple things like that about arithmetic. And that simplifies the proof a lot. But all right. So now we need to multiply or multiply them together. Oh. What was that? I'm still startled when Twitch makes some bingledy bee noise. Well, that was Vern following me. Okay. Yeah. All right. So let's do the same. Let's print them all out. And then, okay, so print sizes. This is just a list of natural numbers. All right, and let's sort them. So, okay. Yeah, we'll just stay using the ML effect so we can fail. We'll just so let's s equals stop sort with um sure, reach out to me at via Twitter. It's the easiest way. I'm the link's on my page. I'm Mark Gritter on Twitter. Be happy to take a look. Let's see, sort with. We have to give it the sort function. And if we want to sort, all right, let's take a look at that. All right, such a way that if compare xy is greater than 0, then x appears before y. All right, what does that mean? So x greater than y. So this is descending order? Yeah, if I return then x is going to be, all right, let's give that a try. If it's wrong, it'll hopefully be obvious. All right. If length of s is less than 3, then we've got a problem. Else we want to return so we return the num minus 1th and the n minus 2nd and the n minus 3rd. And I think we can't put those all to op multiply. We're going to have to use it twice. I'm using the wrong function, I think. It's not index, it's nth. Oh, this is horrible library design. All right. Okay, it's complaining that this function only sorts integers because I let it pick. Why doesn't it know those are the same? Oh, okay. Because I gave it the original instead of sorted, and I took the length as sorted. So it doesn't know that their links are the same, which is actually a problem I ran into the other day and had to. Okay, we need calc part 2. So we're going to collect all region size. And what do we need to do? We need to give it the matrix and start at 0, 0, and give it the empty set because we haven't visited anything left yet, and an empty list. All right. So we want to print sizes, and then we want to print. All right, let's see what that looks like. That's the examples directory. So DFS wasn't too horrible. Passing around that set everywhere was kind of a pain. Fstar does let you do imperative programming, but that's got its own challenges. Okay. So 9, 4, and 19, and their product is 1134. All right, let's see if that works. Hurrah, it worked. All right. How did we do today? Oh, not bad. Not bad. Okay. Well, thanks for watching along. I'm not going to go back and try to repair my part 8 solution. I might do a live stream over the weekend to do that. I'll be traveling next week out to California, but I hope to keep up the live stream at its usual time. It might be a little delayed though. Do I have another? I'd prefer not to give out my email address on the stream, unfortunately. So it's Twitter uh, or chat here. All right. Happy Advent. Thanks to all the sponsors of Advent of Code. That includes my employer this year, Akita Software. Check out our jobs page. I'd love to have you work with us. Take care.